Okay, so let's look at number 11. Number 11 is find the cubic polynomial. So we know it's going to be x to the third of some kind whenever we simplify it all out at the end. And we're going to have the form of the zeros, otherwise x-intercepts, at 3, 4i, and negative 4i. And we don't leave anything with factored form, so no parentheses is what this is saying. Okay, so if we look back and remember, how do we write these zeros or these x-intercepts as actual factors? Is that we're going to set them equal to 0, and we're going to have parenthetic pieces for these factors. So x minus 3 would be the first one, x minus 4i would be the second one, and x plus 4i would be the last one. Just a reminder, these as x-intercepts are where you would plug them in for x, making this whole thing equal 0. So that means if this equals 0, it doesn't matter what these two equal. If it's all multiplying, it's all going to equal 0 at the end. Okay, and that's why we call them zeros, because they're multiplicative forms of binomials that will multiply out to get me that 0. Okay, so we have x here, and again, if we plugged in this 4i here, it would give me that binomial equal to 0, and this right here would fit here where this x value is to make that binomial a 0. So now that we have them set up, we are going to now distribute all these, basically FOIL them all out to where we could have f of x is equal to whatever all this is FOILed out. So let's go ahead and do them in steps. I would suggest, because this is a conjugate pair, okay, remember this conjugate pairs, they came in that plus or minus form with imaginary roots. We should be able to notice that this right here is a sum of squares. Okay, that means you could just straight up take these two values and say x squared, and then this 4 would be a 16, and I know a negative times a positive gives me a negative, but these I squared pieces would end up making this little piece right here a negative 1, which times this negative would just become a positive 16. Now I know that was a lot to regurgitate as far as from your notes and whatnot. If you can't get it that fast, just FOIL them out. Okay, so like x times x, I get x squared. Then the outside terms are plus 4xi. The inside terms multiply to negative 4xi, and then the last term right here, negative times a positive, would give me a negative 16i squared. Okay, these we know will add to cancel each other out to 0, so that we'd be left with x squared minus 16i squared. Nothing has happened with this x minus 3 thus far, but we know we're about to distribute that x minus 3 with this stuff right here that we got from that sum of squares. Now a little recap. We know I squared is equal to negative 1, and this is the one that you're going to predominantly use with imaginary numbers and concepts dealing with imaginary numbers. But sometimes we just need I, which we know is the square root of negative 1. So if I squared is equal to negative 1, we know this is the same as x squared plus 16. And that, of course, is what we got way over here with our little shortcut method. And then all we're going to do now is distribute, because remember, we can't leave any fractions. We're going to distribute these last pieces. So x times x squared gives you x cubed, and then x times the 16, and then negative 3 times x squared will give you a negative 3x squared, and finally negative 3 times a positive 16 will give you negative 48. Now we have our polynomial, but in good form we're going to write it in a descending order as far as their degrees. So the highest degree will be listed first, and then squared, and then the x, just like we did throughout this entire unit. This would be the most simplified form, basically the standard form for what we have. And sure enough, it did match up as far as what we thought it would be as far as the cubic here at the very, very end. All right.